My name is Scott Campbell with Bentley's Technical Support Team. Are you interested in saving money by locating potential sources of leakage and other non-revenue water usage? In this video, I'll show you how to use field data to detect leakage hotspots in Darwin Calibrator, which is a module that you can find in WaterGEMS. Water loss can be an important part of modeling your system, and Darwin Calibrator can be useful in identifying the locations of the water loss. Darwin Calibrator is a versatile tool that uses a genetic algorithm to help make adjustments to the model so that results better match what you're seeing in the field. Here we have a system that we're going to try to locate areas of water loss. First, I'll open up Darwin Calibrator. The first step to doing this is getting useful field data. This can be imported a number of ways, including Model Builder. You can also import existing Scada data through the import function in Darwin Calibrator, as you can see here. Here we have a set of field data that's already been imported. Hydraulic grade and demand data has been included for a number of elements at different times. For this video, we're going to look at the first hour. However, you often will see better results if you have additional times that are applied as well. In this run, we're going to have the genetic algorithm apply different emitter coefficients to junctions in the model, looking for results that best match these hydraulic grade values. If we look at the demand groups, we can see we've entered in a number of the junctions that are in the system. These are the junctions that the emitter coefficient values are going to be applied to. We have a study already created that's going to be looking at hour 0. If we look at the demand tab, we see we are going to be looking at our demand group that we created. The operation's been set to detect leakage nodes. And if we scroll over a little bit further, we'll see that we have our emitter coefficient values set. Minimum value, maximum value, and the increment that it's going to follow. As we've already computed this, we can go ahead and look at the solutions. If we take a look at the solution 1, and we scroll over a little bit to look at the emitter coefficients, we see the original value. In this model, all of the original values for the coefficient was 0. But if we scroll down, we see that we do have some junctions that have a emitter coefficient applied to them. This will indicate areas where leakage or other water loss may be occurring. To better visualize this, we'll go ahead and export this out to a new scenario. By clicking the Export to Scenario button, we'll just go ahead and leave the defaults, which will create a new alternative and a new scenario. Click OK. We'll close out of Darwin Calibrator. We'll now make that new scenario active, and we'll compute it. We already have a color coding set up for this. The color coding is looking at a range of values for the emitter coefficient, basically applying a different color and size based on the value that we have. After computing this model, we'll take a look and see that we do have values for the emitter coefficient that display here. The largest value is over here on the right side, where it's shaded in red. These points indicate where water loss may be occurring and areas that we may need to investigate further in this system. Information on leakage detection, water loss, and much more can be found in the Hydraulics and Hydrology section of Bentley Communities. Thank you for your time.